Students will carry on our sessions with a descriptive understanding of architecture syntax because we have seen till now the different parts of a VHDL program, which was your entity, your libraries, and the key part of a VHDL program is definitely your architecture block. Now, in order to understand what an architecture is, in detail and what are the different styles, we will move ahead. So, just an understanding of architecture is we have two main blocks or we have two main positions of architecture. One is that it consists of the two parts, the declaration and the concurrent statements. What I mean by this is that whenever we design a particular architecture, just below the architecture, or I would say before the first begin of an architecture, we have to do all the declarations, whether we want to use some functions or we want to use some components or groups or subgroups or even signals. So the first part of an architecture will be the declarative part. Now following that, after the begin, we'll have the concurrent statements in an architecture that define the relationship between the input and the output. And in this concurrent assignment, we may have concurrent signal assignment, we may have process statements, components instantiation, concurrent procedural calls, generate statements, and all other features of writing a VHDL program can be included over here. Now, what is my key main focus here today is in our current lab session is that we have different styles of writing in architecture. Please pay attention to this. We have different styles of writing the architecture, and these are mainly four. The first one being the behavioral architectural body. Here I'm trying to make you understand that we can write the behavior in four different ways. By behavior, I mean the concurrent statements that describe the relation of the inputs and outputs can be written in four different ways. The first one is the behavior. By the word itself, you understand that we, in this behavioral style, by this behavioral architecture body, I can name it as behavioral architecture body style. So this is actually a style of writing a program. In this way, you just describe the behavior of the circuit. Say, for example, you look towards the truth table of an AND gate and you describe the behavior of an AND gate such that without giving any information or indication that it's an AND gate, you look towards the truth table and you tell the compiler that when the input is 0, 0, output should be 0. When the input is 0, 1, output should be 0. When the input is 1, 0, output should be 0. And when input is 1, 1, output should be 1. So you're not giving any information about the gate, nor you give any information about the structure of the gate or the circuit. So you just describe the behavior. To state an example of this, say for example, you take up a decoder, BCD decoder. This is the behavioral architecture body. So you have a decoder, you make a process and you define that, you define a case statement over here. Case BCD. That means when the BCD input, which is a 2-bit input, is 0, 0, your output S should be 0, 0, 1. And when the input is 0, 1, your output S should be 0, 0, 1, 0. And when it is 1, 0, it should be 0, 1, 0, 0. And when it is 1, 1, it is nothing but 1, 0, 0, which is exactly the table, or you're trying to map the table of a particular decoder and write it in the VHDL format, and this is what behavioral style is. Okay. Now here we have used a case statement. We can also use with select when statement. You can write this down. There are two ways to do the behavioral description. One is using a case statement. Another is using a with select when. So in nutshell, what we can say is that for behavioral, it is as good as a brute force is used. The VHDL program is using a force to tell the compiler what to do straight away, right? Okay, now let's go to the next style, which is the structural architecture body style. This style, architecture body style, is based on component instantiation and generate statements. If you remember in your C language also, you used to call the functions. Okay, So those functions you can call which you have already written. You have a function, you have designed the code for it, okay, in your compiler or in your system software, you design a particular code. Say, for example, you want to make a calculator. So when you have made a calculator, you have made a function of calculator, and you want to use that for division. So you call that function calculator and provide some inputs, and it gives some output. Similarly, the structural architecture body use components in such instantiation. By instantiation, I mean calling. It is as good as you use function calling. So it allows to create hierarchical projects from simple gates to a very complex component description entire or entire subsystem. The connections among the components are realized through ports. That is, we have ports, input ports and output ports of a component, and therein inputs of a system are supplied to that component through that instantiation, and the outputs of that system are being taken from the outputs of the component that is instantiated. So structural, let's say for example, now you have a full adder or you have a multi-bit adder. So in a multi-bit adder, you use several single bit adders. So what you will do in structural architecture body style is you will make one module of a full adder or of a one bit adder. You will call that over and over again while ensuring that you properly write the input or you properly tell the compiler or the system designer which output goes to which adder and how it flows. So you get exact detail of the structure that which input is for which I mean which particular adder and the output of that particular adder goes to which particular next full adder or one bit adder. So you have a clear idea of the structure in case of the structural description. Now, just to state an example of this, this is a simple example. You have made a inverter beforehand, inverter port map, and this INV1 is actually the instantiation number. And please keep one thing in mind, as I told you, that whenever you design an architecture, in case of especially structural behavioral style, you describe or you declare that component. So you are using two components, so you declare AND as a component. Now please mind this, that this AND gate is not the conventional AND gate that the compiler has inbuilt, but it is you who have designed this before writing a program for this decoder. Before we write the program for the decoder, we first write the program for AND underscore gate and inverter, or I would say in general, whichever components you are going to use in a particular program, you first have to design them and then declare them in the next program in which you have to call them. So this is the declaration part, and here I am calling the inverter, and here I am calling the AND gate. So it gives me a clear idea that this S1 being generated then is actually one of the inputs of this AND gate. This S0 being generated is one of the inputs of this AND gate. So I get the exact mapping or structural idea of the design, and I know exactly which modules are being used. So this is why this is called as structure. So I can generate a hierarchy from the program itself, so as which output of a particular instantiation goes to which particular input of another instantiation. So this is structural. Now let's go back to the main part, which is where we have the third type, that is the data flow architecture description. In data flow architecture description, we use only concurrent signal assignment statements. What do I mean by this is, we use always that assignment operator for every line of code we are writing, such that we have a clear picture of gate-wise implementation, that how a particular function is being generated from a particular gate and which gate is used and how many gates are used. So data flow is a particular style of writing the architecture where I have a clear idea of the flow of the data, from which inputs and which gate is generated and where it finally goes. So information about the structure can be extracted from the description as well. So it has one additional advantage is that obviously when we have two ways to get an idea about structure. One is the structural architecture body, but that is the high level idea of structure because we don't have exact idea of gates. Now in data flow, we have an idea of structure of a particular design, but more importantly, it's a gate level structural description. And every function is being generated by an inbuilt gate or function that is in the compiler. We don't use any of the self-generated or defined, say, functions or some other uh, variables or whichever functions we have made on our own. So these are three main types actually. And fourth is mixed architecture body, where we may have some part which is behavioral. Before we move ahead, let's see the example of a data description of a decoder itself. So this is the decoder. Now you are telling me LED3 is BCD0 and BCD1. LED2 is BCD0 and not of BCD. So everything is done by using an assignment operator. Every line you will have an assignment operator, and you need to get a clear idea of this design, or rather, you get a clear idea of this design by the program itself, or I would say, gate level diagram can be easily drawn by just looking towards the data flow model or data flow style of a behavioral, data flow style of a VHDL program. Now, in order to conclude, we have the mixed version wherein some part of the program is, say, for example, implemented using structural, and some part of program is maybe data flow, or some part of program is behavioral and some part of is structural or data flow. I mean, all these are mixed together. So these are the a few main styles which we can see in our uh, VHDL implementations. And just have a quick question for you. Can you tell me which type of implementation is this? Behavioral? Yes or no? Structural? Yes or no? Data flow? Yes or no? Or mixed? Your answer is okay. Just cross check. Your answer should be data flow, because as you can see, there is only one single assignment though, but everything is written in terms of gates. There is no variable that is kind of generated without using a logic gate function that is inbuilt. So this type is data flow type. Can you tell me which type is this? This is behavioral type. So a multiplexer is implemented as a behavioral type. You don't have any information about gates. You don't have any information about structure. It is just brute force. It's telling us that when D is 0, 0, D is Y is assigned as 0, 0 when D1 is 0. So this is the multiplexer basically. That output is assigned to D0 when select line S is 0, 0. So by this you can also understand the operation of a with select when. This is actually a statement in VHDL. You can note it down. With select when. So with S, select Y as D0 when S is 0, 0. You can read it like this. With S as 0, 1, assign Y, assign D1 to Y. With S as 1, 0, assign D2 to Y. With S as 1, 1, assign D3 to Y. So that is what the type of multiplexer is. So one more question for you. Can you tell me which type is this? Look towards the architecture. Architecture is like this. Case statement is used and no information about logic gates, no information about the structure. So this is again behavioral. Here we're using case statement. So, but remember, case statement you will always use inside a process. With slick one, you can use without a process. So, there, in nutshell, if you want to make sequential circuits, that you have to make using process. So, while making sequential circuits, and if you want to write behavioral style, you have to use case. Okay. And while designing the combination circuits, you can use either case or you can use with select one. So that is the end of today's lecture. See you in the next lecture. Till then, you can revise these concepts and find some basic definitions to any terms that you have missed so far. Thank you very much.